Good morning, everyone. Myself, Dr. Pregya Poonia, working as an associate professor in St. Peter's Engineering College, Hyderabad. So today we are going to discuss about modeling and simulation. So what is modeling? So we can say that modeling, this is a representation of a system where we can see how a system will be working, and if we want to do any kind of changes in the system, by seeing the model we can do the changes in the present model only. So this is a mathematical or logical representation of a system. Now what is a system? System, this is a collection of entities which are interrelated and they work together to achieve the same kind of the objective. So for example, we can see in the manufacturing there are different processes will be going on in the manufacturing factory. So they all will working together, all the components will be working together to achieve the same objective, as well as in healthcare also and in education field also. So a system, it is defined to be a collection of entities. Now what is an entities? Entities can be anything. This can be people, this can be a product or a machines which are acting together to achieve some kind of the logical goal. So now what is the system is having entities, it is having attributes, and it is having activity. Now what is an entity? Entity is something for which the system has been designed. So for example, if we take the example of the college, so this college has been designed for students. So students come here and they get their educations and they leave the college. Now attribute is the property of the entity. Attribute is for what purpose the system has been designed. So the system has designed for entities, and the entities are entering for the purpose of the education in the college system. So education, this is the attribute. This is the attribute for the entity, for the student. Now activity, what is the activity? Activity is for how much time the entity is there in the system. So for example, the students are coming in the morning, they are coming here for the purpose of education, and they are staying here for 4 to 5 hours or 6 hours, and after 6 hours they are leaving the system, the college. So this is how the modeling and simulation works. Now if we take an example in banking system, customers, they will be coming, so customers will be the entity. Now for what purpose they are coming to the college? Whether they want to deposit the money or whether they want to check their balance. So for example, if they are coming to check their balance, then the balance in their checking accounts, that will be the attribute for that particular customer. Now after checking, if they have checked their balance, then how much time have they taken to check their balance, that will be the activity in the system. So that will be called as the activity. Next is, now what are the types of the system? So a system can be divided into quantum system, continuous system, and discrete event system. So in modeling and simulation we will be studying about discrete event system. So what is a discrete event system? Is discrete event, as event is mentioned there, it means at every step some kind of event will be happening in the system. So for example, students have come in the college, that is the first step, and after coming they are taking their education, so that is the second step, second event we can say. And at the third event, what will be after education? They are leaving the college. So at every step some kind of event is going on in the system. Now discrete, these kind of things, they are basically used in the industries. So industries, so discrete, these are like, you can see there is a graph like this. So time, we can see at time 1 some kind of event is happening, at time 2 another kind of event is happening, at time 3 again some type of event is happening. So that is the what is the discrete system will be calling as. So next, the system, again we can divide the system into experimenting with the actual system, or we can experiment with the model of the system. So experimenting with the actual system, this is very difficult. It's like if you want to make a house, so first you have constructed the house and now you want to do some modifications in the house, that will be very difficult. So rather than building the system previously, what we will do, we will design a model for the home. So we will design the model, we will experiment with that model if we want to do some kind of changes, and then we will go ahead. So experimenting with the model of the system, this is very easy. So again this will be divided into physical model or mathematical model. So in physical model, it's like this will be a very small scale kind of the model where we can do the changes. Otherwise we will go with the mathematical model. Now this mathematical model, again it is divided into two types. First is analytical solution and then simulation. Now what these models are working in real life, what will happen? First we have to decide, first we have to find the problem in a system. So for example, there is a system, so in that system we will try to find the problem. So once the problem has been defined in the system, we will prepare a model, we will construct a model, and that model either we can apply analytical model or we can apply the simulation model. So after this there will be some results, so then we will do the optimization of the model. So there will be, after doing this modeling, after applying analytical and simulation method, there will be many solutions. So from those solutions we will be choosing the best one solution. So that best one solution we will be again feeding back to the system. So with this kind of things, with this kind of model, what we can do, we can define a problem, we can identify a problem, and then we can solve the problem. Next is, what is a simulation? Simulation is, we can say, this is a process of running a computer model of a real system. So this is before designing, before constructing a model, what we will do, we will make the computerized model, the logical model, and that will be called as simulation. So this, we do simulation for the purpose of understanding the model and its behavior. Next is to see the strategies and the operations of the system. Now for example, in real life, if we see, if we want to know some kind of way to go somewhere, a path, then what will happen? Then what will happen in real life? If we want to find the path, we have to ask people. Now that is a problem in the real world. Now to overcome that, what we have done, we have come with the maps. So with the help of maps, what we can do, we can just give the destination, and on the basis of the destination it will give us different paths. So it has given the solution to the real life problem. Next is, so in simulation what happens, there will be a real system. That real system is, we will apply the model in the real system, then we will do the experiments, and modeling we can do, either we can apply analytical model or we can do simulation. So this process, modeling and then coming with the experiments, this process will be called as simulation. This particular process will be called as simulation. So in simulation, what we are doing, first we are modeling the system. In this we will be having input variables. Input variables these are the parameters which will define the system. Then output variables, these are the parameters which will give you the performance of the system. Then based upon these mathematical and logical relations between, we will see what is the mathematical and logical relations between input and output. Then we do the experiments. With experiments we will generate the best outcome, or the best result, or the best solution for the existing system. And then performance measures, these are the, we can say, these are the properties of the systems which are having the problem. Next is system model. What type of simulation system models are there? First is deterministic, second one is stochastic. So what is the deterministic system is? Deterministic system is where we know what will be the output. Every time we know what is the output, it will not change with the time. Deterministic system will not change with the time. So for example, if we say yx is equals to x square, then we know every time whenever we are computing this equation, we know what will be the result. So this kind of things, these will called as deterministic model. And then stochastic models. Stochastic models are those which are changing with the time. So whenever the model is changing with the time, the parameters are also getting changed with the time. So if I take an example, real life example, if you are a manufacturer of something, then in manufacturing you know that how many units you have to make in a day, and to make those units how many hours will be taking, or we can say how much time it will take to make the product, and then how much or how many people or the labor will be needing for this. So this thing you know, it means that is the deterministic thing. Now what is the stochastic thing is, you know what we have to make, how much time it will take, and how many labor we need. Now you don't know when the customer will come. You don't know when the customer will come and how many quantity of that particular product that customer will be asking you. So that will be the stochastic model. So in deterministic, you know what you have to do and what will be the output, and in stochastic you don't know what will be the output. Now these, they are changed. Again they have, deterministic is static and dynamic, same. Stochastic is also is static and dynamic. Now static, in this static is, does time have any role in that particular model or not? So that will be static. If it is changing with the time, then the system will be static, and if it not changing with the time, then this system will be deterministic. Again this dynamic is divided into continuous and discrete. Continuous is which is going continuously like a wave. It is not getting affected by any kind of parameter changes or anything. And what is discrete? Discrete is, as we have discussed earlier also, that at every step some kind of event will be happening. So this is event based modeling. Next is, if we are going with deterministic and if the system is dynamic, then we can go with continuous simulation, or we can go with discrete simulation. Now in stochastic, what will happen? If we are going with the static modeling, then there is the method which is called as Monte Carlo simulation. We will go with that. And if it is stochastic and it is dynamic, then again it will be divided into continuous and discrete. Then we will be applying continuous simulation and discrete event simulation. So that's it for the day.